Sir, you start your video now.
Yes, sir. Can you see my video?
Yes. You stop sharing now, sir.
No, I'm not getting you.
PPT, you don't share right now.
Okay, shall I? Yeah, okay. Yeah, I have cut my PPT.
Thank you, sir. We'll start the
Yes, sir.
session.
Yeah, please, sir. Yeah.
Thank you, sir.
Okay. Good morning, one and all. I, Professor Vijay Shinde, welcome you all on behalf of Bharati Vidyapeeth, deemed to be University, College of Engineering, Pune, on 6th day of 1 week online faculty development program on research in energy technologies organized by Department of Mechanical Engineering. Today's topic is wind energy. For that, we have K. Boopati with us as a resource person. Currently, he is a director and division head R&D and resource data analytic and forecasting NIWE. He is basically a mechanical engineer, received master degree MTech in energy engineering at Regional Engineering College, Trichy, and footwear science and engineering at Anna University, Chennai, and is currently pursuing PhD. He entered as a faculty at Engineering College and VIT University. He has been appointed in January 2003 as a scientist in National Institute of Wind Energy NIWE, in which he dedicated to assess the wind resource potential of India at 50-meter height and successfully published for public. He prosperously led Wind Resource Assessment Unit as head of the department from February 2012 to April 2017. He successfully launched the National Wind Power Forecasting Project and received SKOCH Scotch Award in 2016, E-Governance Award in 2019, Best Forecasting Award in 2019, and Merit Order Award for Solar Power Forecasting. He successfully developed 50-meter, 80-meter, 100-meter, and 120-meter height wind map and published it. He has been providing consultancy for leading government organizations, public sectors, and private organizations, such as wind farm design and development, analysis of existing wind farm operations. He has also been involved in various research projects such as offshore wind profile measurement and wind characteristic study in complex terrain. Other activities have included wind resource training to various officials, colleges, faculties, wind farm developers, involving preparation of India's onshore and wind and solar hybrid policy, Island hybrid wind diesel power systems. Currently, he is looking after research, development, and resource data analytics and forecasting divisions and has been leading the various division prosperously. Now, I request Mr. K. Bhupati, sir, to start the session.
Thank you, sir. Thank you for giving wonderful introduction. Yeah, so now I would like to start my presentation. So before starting my presentation, I would like to express my sincere thanks for inviting me to give lecture on wind energy and its technology. And also, I would like to thank your management and Professor yourself and your department staff. Thank you, sir. Once again, I would like to say thanks to you. Now, I would like to start my presentation. Can you see my presentation, sir?
Yes, sir.
Yeah.
So,
Vanakkam, sir. Namaste. Good morning. So we always say that, this situation we always, we have to bring our hand together, not for shaking hand and other things. So this is our traditional way to say Vanakkam, good morning, and namaste. Yeah, so that just I want to just to share it. Yeah, just you have given an introduction about me. Yeah, just a minute. Yeah, yes, sir. So this is my introduction already, sir, has given to me. The slide is not moving. One moment, yeah. Okay, sir. Yes, sir. So before starting my lecture, I would like to say a few words about our National Institute of Wind Energy. So National Institute of Wind Energy, which is located in Chennai, and we have one more office in Kayathar. It's 600 kilometers away from Chennai. So we have the various divisions. The one is that the wind solar resource measurement. We have been collecting data from various locations, both wind and solar resource, to identify where the wind resource and the solar resource locations are available. So that is the wind solar resource measurement. Sir, some crosstalk is there. Hello, some crosstalk is there, sir. Yeah, so that is the wind solar resource measurement and research and development and resource data analytic and forecasting. Research and development, we have been associated with various colleges and universities doing many research activities. Like the blade profile development, microgrid, and for small wind hybrid system, and various other projects we have been doing associated with the various colleges and universities. And also apart from this, also we have intensive program for both the staff and students. The students and the staff, those who want to take intensive program in our organization, they can apply directly from net. So we will, we will scrutinize the application form and will, just send the confirmation to do the project work in our office, both intensive as well as the project work. And also, sir, the next is certification and information technology. We have a testing and research station in Kayathar, 6 km away from there. There we are doing a testing of small wind turbine as well as the large wind turbine. And after doing this testing, then we do a certification. And also we are giving skill development and training. We are giving training for both students as well as staff. And for industrialists, those who want to take training from us, they can apply through online. You can get a training both national level and international level. National level it's happening for 5 days, and international level it's happening for 30 days. And international level participant only for international only can participate in this training program. And also we are doing the standards and regulation. Then solar radiation resource assessment, we have been doing it. So currently we have already measured 969 locations wind measurement station. Those data we have it. Those who want to do any research work, they can directly approach us to do this research. We always help for the student and staff. And for the solar radiation, we have 125 locations across the country. Every 100 kilometer one station we have it. So we have nearly some of the stations up to 50 stations we have 10 years, 9 years data, and the remaining 60 stations we have 5 years data sets. So these are, this is about our organization. Now the solar resource assessment, and now you can see in the left side graph, you can see the location where we have the solar resource assessment. So we have the two different phases we have done it, and also we have the advanced measurement station also. Apart from the solar radiation measurement, we have additional measurements also. We are doing the aerosol particles, and for the spectrum, we are getting from there. So this is about our solar radiation resource assessment. Yeah. So now I would like to start my presentation. That is the introduction of energy. So everyone knows that energy. What is energy? So energy is nothing but it's the capacity of doing work. That is the capability to do work. If you want to run, if I want to talk to you, then if you want to hear from me, we need energy. So without energy, I can't talk to you also. You cannot hear me also. And also for cycling, running, what aeroplane, car, and whatever the things you want to know that, I mean, you want to run, you need energy. Where this all those energy we are getting from? We are getting energy from different resources. What are the resources? You know that the conventional energy we are getting from coal, thermal power, I mean coal, thermal power plant, nuclear power plant, hydroelectric power plant, solar power plant, wind power plant. It's like this, you know, biomass gasification, biomass power plant. Like this, you know, various power resources are there. From the resources we are, you know, generating electricity, right? Even though we are generating electricity from conventional energy sources, you know that it is destroying our environment. How it is destroying environment? You know, when the thermal power plant, when you are burning coal, so it's you know, it's destructing our environment, air quality. And for even the hydroelectric power plant, even though it is a hydroelectric power plant, it's a renewable energy resources. When you are drying up the entire water, then what will happen? The aquatic culture life is getting damaged. And also for nuclear power plant, when you are generating electricity from nuclear power plant, you know, that is radioactive waste. It's emitting, you know, radiation to the atmosphere, and you know, it's affecting our people. So then we have to go for only the energy from, that is renewable energy resources. That is, it's going to happen. So renewable energy resources till date in our country, 87 gigawatt already we installed. The total installed capacity of wind, solar, biomass, and thermal energy is 370 gigawatt. Yeah. So 370 gigawatt already we installed. Out of 370 gigawatt, 80 gigawatts, 87 gigawatt from solar, I mean 87 gigawatt from the renewable energy. You know, the government of India has set an ambitious target to reach 175 gigawatt by 2022. So 2022 already we reached 87. Till, you know, we only the 2 years how we are going to reach 25 gigawatt. And also not only this one, even the government has set an ambitious target for another target for in 2030 almost the 450 gigawatt. So 450 gigawatt from the renewable energy resources. Then imagine it, how we have to move forward. How we have to move forward, and also then how we are going to achieve it, and the importance of the renewable energy resources. Yes, yeah. So that wind, what is the wind? So wind is nothing but is the motion of air related to the Earth's surface. It makes a calm from one day it may very calm wind. You may feel that one day it may very less wind speed will be there. Another day it will be the very high wind speed will be there. How you can hear it? You may hear that is a howling sound. When you have that the high wind speed, you might have seen transmission line. The lines will be there. It will make sound. Whoosh sound will be there. So that means that that location has a very high wind speed, and also the wind will vary from place to place. So where you are now, you are in Pune, and in the Pune you are now in the Pune. It may be the 3 meter per second. If you go to Satara region, then it will be the 8 meter per second. It means that the location wise, the wind speed will vary from place to place, and also the time to time. It may in now the time wind speed will be the 3 meter per second, then all of the next second it will go to 5 meter per second, next second it will go to 5 meter per second, next it will go to 10 meter per second, then again 8 meter per second, like this. The wind speed is vary from place to place and the time to time, and also season to season also. What is the season? It may be that the windy season. We always say that, but wind everywhere it is there. Wind is there. But what is the then? The wind is everywhere it is there. But the thing is that the wind which is required to start rotating the turbine, that is the variation. That variation will be there. So generally we have the wind speed during May to September only. May to September. That is the season to season. And also the wind will vary from height to height also. Height. At a lower height, the wind speed will be low. For example, this is a 5 meter per second, this is 8 meter per second, this is a 10 meter per second, this may be the 10 meter height, this may be 50 meter height, this may be the 100 meter height. You can see the wind speed will vary from place to place, and time to time, and also the season to season, and also height to height also will vary. See, at 10 meter height, I have the 5 meter per second, and 50 meter height, I have the 80 meter, 8 meter per second. At 100 meter height, I have 10 meter per second. So it is, I mean, the wind speed is, variable. Variable should not in the constant one. And also, yeah. So this is the things about that is the wind energy. And the next thing, so the resource, how where the wind which is originated. The wind which is originated. So all the energy which is coming from the sun only. Sun is there is a mother source of energy. So we are getting even fossil fuel, the coal, petroleum. How we are getting coal and petroleum? Because of the sun only. Because of the sun energy only, we can live in the earth. All the energy which is coming from sun only. Out of that is 1 to 2% of the energy which is converted into wind. The remaining part of energy which is coming to some other source of the energy. Okay, how is the wind is originating? You know that during daytime, the sun rays which is falls on the earth surface, the above the earth surface you have the movement of air. That is the mass of the air will be there. So when the radiation falls on the earth surface, the air will become heated. Once the air is heated, the density, the air reduce the density. Once the reduce the density, the lower density will go up, higher density will come in. Where the higher density? Because the earth which has a different mass, that is earth mass and water mass. Okay, during the daytime, the earth will absorb that is more heat compared to water. Water will absorb that is a slow absorption of the radiation. And during the daytime, what will happen? That's vice versa. And also the rotation of the earth, the wind which is originated. Okay, then wind which is okay. Then power. How much power available in the wind? So we know the mass of air. That is the mass of air which is moving. Right. So when the mass which is moving from one place to another place, that is what is the kind of energy we have it. That is kinetic energy. So for example, the mass is here. It has the potential energy. When it is moving from one place to another place, its potential energy converted into kinetic energy. This is the kinetic energy. Even though the wind is even though it's a less substance which has some energy. What is the energy? That is the kinetic energy. That is the mass of the air. So we know that kinetic energy equal to half mv square. That is the formula we have derived. You might have studied in physics. And what is the mass? That is the m. M is nothing is the mass flow rate. How much is the mass of the air which is flowing through an area? This is an area. Okay. When the mass of air which is flowing through an area, then we have to take into consideration of rho, area, the density, and area, and velocity. That is now if you just calculate power available in the wind equal to half. That is m is equal to nothing but rho a v. Then it's v squared. Then v squared that is equal to half rho a v cube. That is power available in the wind is half rho a v cube. Okay, then perfect. Power available in the wind is half rho a v cube. When the wind speed is 2 meters per second, what will be the power? Power will be now the 8 watt. When the wind speed is 5 meters per second, now the power will be 125 watt. Now you can see the difference. Even the wind speed changes only the 3 meters per second, but the power changes, that's the 14 folds, 14 times it increases the power. So now you can think about what is the power of the wind. That power of the wind is that is a many times because there is a cubic relation. Power is directly proportional to the V cube. Now that you can see here this graph. This graph what it shows that there is the wind speed and also this is the power. Right. So the power and also then before scale which is says that when you have that is a less than 6 meters per second is a moderate breeze wind. And if you have that is up to less than 12 meters per second, it's a strong breeze 6 to 12, and 12 to 18 meters per 16 meters per second it's a near girl, and in the next 18 to 20 meters per second is a girl wind speed, and it's a severe girl, that is a storm will be there. And you can see here this is the power curve. What is the power curve? That is a power curve which is derived by the manufacturer. So manufacturer, when they want to design the wind turbine, they know that how much power it will generate. So based on that is a many formula. So now we have seen that the power formula equal to that is a half rho a v cube. Then it's a CP. That is the power available by the power developed by the turbine. CP is nothing but there is a power coefficient. I will tell you what is the power coefficient. Now, yeah, this is the power curve derived by the developers. Designer. See how much, what is the wind speed, what is the power available. For example, this is a 2 megawatt wind turbine. So 2 megawatt wind turbine, it's slowly when the wind speed increases, the power also just increases. When it reaches What is the rated wind speed? Rated wind speed is 15 meters per second. When it reaches to the rated wind speed, when the reaches to the rated wind speed, the turbine also will generate rated power. What is the rated power? That is a 2 megawatt. I have designed my turbine. It can generate 2 megawatt or also 600 kilowatt. I have designed my turbine 600 kilowatt. This is my, that is the maximum capacity. That is 600 kilowatt, 2 megawatt, 3 megawatt, 5 megawatt. Whatever it is, it depends on the design. Yes, this is the potential. This is the potential map which is available in our website. Okay, it is available in our website. You can see here initially, we estimated the potential 49 gigawatt at 50 meter height, and 80 meter we have estimated 102 gigawatt, and for 100 meters is a 302 gigawatt. Then this is a 20 meter not exactly we have estimated. Just we have given the map, but 120 meter we have almost 700 and 690 gigawatts. So this is from our estimation. This is the estimated potential in our country. Now, in case if you want to know about what is the wind speed and the wind power density, so wind power density is nothing but how much power available in square meter. So this is the rotor area, and each square meter, what is the power available? So that's called that the wind power density. Then now you can see that when you click in this portion, then you will find out. Then if you want to know that exactly what is the Pune, your college, then you write the latitude, longitude, or you click that particular location. You will come to know that what is the wind speed, what is the wind power density, what is the capacity utilization factor. All these factors we can get it. And also apart from this, also you can see the solar radiation. Then first thing I have shown here. Yeah, if you click any location here, then you will find out what is the wind speed. This is a 3 kilometer by 3 kilometer resolution. What is the solar radiation? What is the global horizontal irradiation? What is the direct normal irradiation? What is that is a diffused horizontal irradiation? All these things you can find out from here. And also we have developed an app that is called Surja. This application is available both Android as well as iPhone. For iPhone for this purpose. From this, just you can see that if you click it, if you download it, you can find what is the wind speed and where it is there, what is the solar radiation from there, and the solar. Even if you want to know that what is your surface area of your roof, then you can find out how much energy can be generated. So those kind of information which is available in the Surja applications. Yeah. Not moving. Sorry, sir, it's not moving. Just a minute.
Okay.
That's moving now. Yeah. So this is our potential, the color code. Yeah, this is the color code. The color code which indicates what is the wind speed, what is the wind power density, what is the capacity utilization factor. So you are all mechanical. Most of them I came to know that you are all mechanical engineers. So mechanical engineers, you know that what is the turbine generation. You might have heard about the plant load factor, yeah, PLF. That is the plant load factor might have studied in thermal power station. So plant load factor, what is the actual generation? Actual generation divided by the maximum generation possible. So that is called here is the capacity utilization factor. So all this information you can get it. Okay, then how we are getting the data from, how we are collecting, how we are getting this measurements. So measurement, we have to install a meteorological mast. This is a meteorological mast. Even for IMD, they are installing 10 meter, but we are installing, and in the private developers also installing, depends on the requirement of the height, turbine height. Okay, this is the 100 meter height. This is also the 100 meter height. This is the onshore. It means that install on the land, it's installed on the installed in the sea. That's called that is the offshore, right? And also we have mounted instruments. We have mounted instrument at a different location, different height. You can see here different height we have installed, mounted the instruments. What are the different types of instruments? Cup anemometer, van, ultrasonic, hot wire anemometer, and other devices. Then I will explain to you. And yeah, so these are the instrument. These are the instrument. This is called that is anemometer. This is a cup anemometer because it looks it's a cup shape. Because when the wind, when it contact the cup surface starts rotating, the number of rotations is directly proportional to the wind speed. You can see here the cup which is coupled to the shaft, and here we have the some other devices. mechanical devices or electrical devices. Sometimes it may convert it into what's called the voltage, then voltage signal. Then from the voltage signal we'll find out, or the current signal we'll find out. And this is the wind van. We can find out which direction the wind is blowing. For example, now it's the north, this is the west. Now the wind is coming from western direction. The shaft goes towards the western direction. This wind it comes to, that is the lee side, the van. When the wind is coming from now it is in the southern direction, the shaft will come towards the southern direction, and the van will go to the lee sides. Okay, now this is the lower location because the wind is coming from this direction. And also this is a data logger. The logger which stores the energy, stores the data for 1 minute or 10-minute average or 1 hour average, whatever the things you want, you can store the data in this one. Apart from this, also we are measuring the pressure, temperature, pressure, and it's the humidity. So you know the relationship, there is a PV is equal to nRT. You might have studied, because thermal engineering you might have studied, and you know that now we can find out the rho. There is a density we have to derive it. That is a P by R. So the rho is nothing a density, because the power is equal to half rho A V cube. This rho cannot be measured. Then we have to derive. So that's why we are measuring the pressure and the temperature. Pressure is, there is atmospheric pressure. R is the gas constant. T is, there is the temperature. Yeah. So this is the normal conventional measurement, and also apart from this, also we can use remote sensing devices. Remote sensing. That is means without any physical contact, we are getting information. That's called, that is a remote sensing. Like, you know, every day you are using your TV remote and for AC remote, how you are giving the information. Remote. That is a remote. You have the remote. You are telling you want to change the channel. You are changing the channel. Is there any physical contact? No contact. Now you are directly just changing it. This is also for this also. This is called the sound detection ranging instrument. Sound detection ranging instrument. So this is the sound detection ranging instrument. You can see here. See the meteorological mast. We have to install. Find the location. We have to install. We need for 100-meter mast, mean 100 by 100-meter location area need. But here it's a very less area. At least 10 meter by 10 meter is enough. 10 meter by 10 meter location is enough. We can install because this has the antennas. So this is called the antennas. It's a transducer, it's the emitter as well as the receiver. It's the emitter as well as the receiver. So it's emitting sound to the atmosphere. So sound to the atmosphere, what is the speed of the sound? That's 340 meters per second, right? So the atmosphere, which are the inhomogeneous temperature particles. So when the particles moves along to the wind, when it sends the sound signal, it go back to the antenna. So once it's echo back to the antenna, by using this fast Fourier transformer, we'll find what is the wind speed and wind direction. That is nothing but that's the wind speed. So horizontal wind speed, we can measure the three different direction. That is a horizontal wind speed, vertical wind speed. I mean horizontal. I mean east west. There is the zonal wind speed, and you know north north and south there is a meridional wind speed. One is the vertical wind speed. That is the three wind speed: east, north, and vertical. These three wind speed. Then when you are combining together, I mean horizontal wind speed equal to, that is a u squared plus v squared plus w squared. That's a root. That's called wind speed. And also when you want to find out what is the direction, which direction the wind is blowing, theta equal to tan inverse of u by v. Right. So this is called, next is the LiDAR. LiDAR is a light detection ranging instrument. Instead of the sound, we can use light. So you know the light speed 3.1 into 10 to the 3.1 into 10 to the power 1 into 10 to the power 8 meters per second. Right. Sir, can you hear me? Hello. Hello.
Yes, sir. Yes, sir.
Sir, you can hear now. Yeah. Okay. Right.
What is the application?
Yeah, I thought you are not. Pardon, sir?
You have
Hello?
said you have developed the application, Swaraj. Can you just?
Surja. Yes, sir. The Surja. So you can find out what is the potential, where the potential, how much it is there you can find out. Hello,
Okay, sir.
you,
Okay, sir. Okay.
Okay, now I can go ahead. Then finally we can ask, and finally we can discuss, right, sir? Okay. So this is a light detection ranging instrument. The light detection ranging light sends the light signals to the atmosphere. The atmosphere is the aerosol particle. since the aerosol particles moving along to the wind, when it hits on the surface, the frequency changes. I'll send some frequency, then after hitting the surface, depends on the wind speed, the return frequency will change. So accordingly, I can find out what is the wind speed and direction. So you might have seen under this, since you are in the Pune. From Pune, you can find the Satara region. We have the many number of wind turbines there. If it is the single turbine, is called the turbine. If you have the many number of turbines, it is called that is the wind farm. This is called the wind farm, right? So turbine. So the turbine has more than 8,000 components. One single turbine has more than 8,000 components. Now we are going to discuss about only the major components. So these are the major components. The rotor. The rotor is nothing but it's a hub. I mean combination of hub and because the rotating part of the outside. The outside, then you can visibly see. So that is the blades. The blades and the hub is called as a rotor. Nacelle. So nacelle is here. So this entire thing, sir, this entire portion is called that is a nacelle portion. A nacelle and a drivetrain. So drivetrain is nothing but here the inside the nacelle will be there, like shaft, gearbox, and generator, bearings, everything will be there. That's called the drivetrain. And the mainframe. So mainframe is nothing but all the components are the drivetrains are placed on the mainframe. That's called the mainframe. And EOS system I will explain to you. And the tower. So the tower, you can see here is a tower. Just the tower with the tower with included view of the inside the nacelle portion. So you can see here is the hub which has the portion which has the hub which allows the blades enter into the side. So this is called the hub. Here we have the shaft. There is a low speed shaft. There is a gearbox, and other many components are there. So now you can see it is the hub. So the hub, you can see here we have the bearings, because the this is called the one bearing. This is called the shaft, main shaft, because the hub which is coupled with the shaft, and also the blades. Some of the turbine technology has the bearing. The blades are fixed on the hub through bearings. Here we have the bearing, but some of the turbine they may not have the bearing. Then I will explain to you later. This is called the drivetrain. What is the drivetrain? Because now our purpose of the wind turbine is it has to generate electricity. We have to convert the linear motion of the wind speed into rotary motion. The rotary motion from the rotor we have to transmit to the generator. How we can transmit? Through the drivetrain, through the mechanical elements. These mechanical elements are called the drivetrain. What are the different mechanical elements are there? Shaft, gearbox, and this is one another shaft. This is called the low speed shaft. This is called the high speed shaft, because generally the turbine rotates at, for example, is a 10 rpm. Since the hub which is coupled with the shaft, directly coupled with the shaft, the shaft also rotates at 10 rpm. That's why it's called the low speed shaft. But here generally this is 10 rpm, but the generator needs 1000 rpm, for example. Then we in between we have to step up the speed. How we can step up the speed? In between we need the gearbox. That is speed 10 by 1000 is 1:100. So 1:100 ratio I have to convert. How I can convert to the 1:100 ratio? Whether I can use that is a parallel shaft, because the mechanical engineers know that parallel shaft gearbox or planetary type gearbox. So parallel type gearbox I can't use it, because it will become there is a bulge. It depends on the capacity. In case if it is a low speed, I mean in case if it is a low capacity turbine, for example, less than 500 kilowatt, I can use that as a parallel shaft. In case there is a megawatt class of turbine, I cannot use there is a low speed, parallel shaft gearbox. I have to use planetary gearbox, because the planetary gearbox is a multiple advantages. It's third, and also the transmission also it's a very high, and also that we cannot use completely the planetary gear. We may use it the different way. So half of the stage, or the last stage. Mostly we use the last stage. That is more at the last stage is a parallel stage, and the remaining stage are planetary stage. Parallel and planetary. That will give that is the more advantages. So this is, and also the control system. The system, the turbine which has the control system, because control system is most important for each and every everything. For example, in human being, do we have the control system? Yes, we have the control system. See here, I'm talking to you. If I want to talk to you higher speed, higher sound, I can talk. And where it is coming from, the information. Suppose we are traveling by 60 kilometer, 80 kilometer, all of a sudden a person who crosses, how you are controlling yourself, how you are applying the brake, because your eyes is that's the instrument which measures. Okay, then somebody is crossing it, then it is giving the information to brain is your control system, the brain which is says that okay, please apply the brake, then automatically your legs goes there to apply the brake. This is the control system. The same way, I want to control my turbine. How I can control? Why do I want to control my turbine? Because even at the low wind speed, my turbine has to extract the maximum energy. When it towards the higher wind speed, I have to stop my turbine, because otherwise my turbine, it will flown off by the wind. So I have to control. So this is the way then we are controlling the. Yeah, the turbine which has, the one control will be on the top of the tower, other control will be the bottom of the tower. That is the two location. Top of the nacelle will be there. This is called the slave controller. This is called that is master controller. This is called that is the master controller will be there. So how does the wind turbine work? You know that. So the blades. So the blades are the blades. Yeah, the yeah. Here actually the wind turbine blades. So the wind turbine blades are not like our ceiling fan blade. The wind turbine blades are completely different. This is aerodynamic. It's a design. You might have studied even aeroplane wing also, which is having the same shape only. So same shape. Now you can see here this is the wind turbine blade. Yeah, this is aerodynamic shape. When you are placing the aerodynamic shape of the, aerodynamic shape of the blades in the pool of the wind, the wind turbine blade, it extracts energy from the wind, because it's a linear motion, that is a kinetic energy. This energy being extracted by the rotor, that is the blades. Then after extracting it, it transmits to the rotary motion. The rotary motion is this rotary motion. The rotary motion is transferred to the generator. How it's transmitting to the transmission? That is through drivetrain components. I told you. So this is the drivetrain components. Drivetrain components, then it will transmit to the generators. So this is the basic principle. How it is working, you know that. So this is the blade, right? This is a curvature blade. Okay, when you have there is a curvature blade, when the wind is hitting on the surface, what will happen? The wind will become divided into two parts, right? This is the blade. You can see the blade. So the aerodynamic shape of the blade will be like this only. Number of aerodynamics, all the locations will have the aerodynamic shape only, the entire blades. So when the wind hits on the surface, what will happen? And wind will become divided into two parts. The upper portion will move faster, and the lower portion will move slower. And so due to this difference, then what will happen? The Bernoulli's principle. What is the Bernoulli's principle? It means that if the high velocity means the low pressure, and high pressure means that is a low velocity. Then high pressure region always try to move to the low pressure region. Then automatically it's happening the lift. There are four forces acting on the surface. One is the lift force, other is the drag force, there is a gravity force, there is a thrust force. You know that the lift force. See, when the wind hit on the surface, it will try to lift the blades up, and other forces is just a drag force. So this drag force will be less, and lift force will be high. Then other force trying to bring down your turbine down, that is called gravity force. Other force try to tumble your blades, that's called the thrust force. These are the four forces acting on the blade, right? Yeah. So the torque. So what is the torque? That is the mechanical force. So what is the conversion methods? The conversion method is the basic principle operation is, so initially extract energy from the wind. Then this kinetic energy will be converted into mechanical energy. Then mechanical energy will be converted into electrical energy, right? So this is the conversion is happening. The kinetic energy, mechanical energy, then electrical energy. What is here? This is the mechanical energy. So mechanical energy, you know that. So when the wind force act on the surface of the blade which is mounted on the axis, then it will create power. What? There is a mechanical power. The mechanical power torque into speed. That is the torque into speed divided by the constant. That is, that constant is nothing but is a gravity constant. Okay. So this is the mechanical power which is generated. How the mechanical power is generating to the electrical energy. Now, so once the force which acts on the surface of the blade, it starts rotating, correct? Just it starts rotating. Once it starts rotating, depends on the wind speed. In case with a low speed, then it start rotation, just try to start rotating. when the force is more, when the wind force is more, can it, if it can, I mean, it can, against the resistive force, then what will happen? It start generating electricity. So what is the maximum power it can extract? The maximum power extract is, that is a 59.3% only. So it is derived by the beds. So how? See, this is the actual wind which is coming from here, and here 2/3 of the wind only is being extracted by the rotor. This is the rotor turbine. 2/3 of the power only is being extracted from the wind. This is the 100% wind. So here 2/3 of the wind, because the wind turbine, you know, the wind turbine blade, the wind has to pass through the blade. That's why the wind, when we'll get that, it's a maximum, that is 59.3%, when the blades intercept the air by 2/3 of the time, 2/3 of the wind speed, then you will get that is 59.23%. The 1/3 of the wind has to blow through the blades. So that's called the power coefficient, rotor efficient, and the power coefficient. That is called, that is the CP. So CP, that is how much of the fraction of the wind power extracted by the blades. So that is called, that is a fraction of the wind power extracted by the blades. That is the total power available in the wind. I know there is a 100% power available, right? I know that. How many fraction of the wind? I told you only the 2/3 only. So 2/3 of the wind power only can be extracted by the turbine blades. That's called, that is the power coefficient, right? That is a mechanical power equal to, that is the wind power into CP. So that's called the power, power developed by the turbine equal to half rho A V cube into CP. CP is nothing but the power coefficient. You know the power coefficient, fraction of power extracted by the blade with the power available in there. This is the most important thing, that is the power coefficient. Right. So now the axis of orientation. Now you can see here, axis of orientation. This is the blade. Right. This is the horizontal axis wind turbine. This is the vertical axis wind turbine. Horizontal axis. The axis of rotation is horizontal because it's parallel to the ground. That's why it's a horizontal axis wind turbine. This is the vertical axis wind turbine. So the vertical axis wind turbine, the axis of rotation is perpendicular. You can see this is the ground. This is the perpendicular. That's why it's called the vertical axis wind turbine. This is the horizontal axis wind turbine. So what is the advantages of both? You can see, I told you all the drivetrain components are placed on the top of the tower. That's all. What is the other advantages we have it? I told you the wind speed increases the height, correct? So if I want to, then if I increase the height to 120 meter, this is the 120 meter height, I can get 15 meter per second. Just I'm telling that 15 meter per second. It's well and good. Even if you have the height is less, I can get only the 8 meter per second. For example, 80 meter height, I can get only the 8 meter per second. So if you increase the height of the turbine, you will get, that is more power. That is advantages. So other disadvantages mean, see, whenever the wind is coming from this direction, okay, perfectly it's orienting towards this direction. When the wind, okay, then 2 months, then you will lose the power. But here the advantage is, here all the components are in the down. Then any mechanical, any the O&M personnel can repair within 2 to 3 days. And here, any direction of the wind, it can take any direction of wind, then it can start rotating. But here the disadvantage is, we cannot go beyond certain capacity. See, the capacity of the maximum in the world is 4 megawatt. Sorry, 4 megawatt of turbine, 4 megawatt turbine. But here it is a 12 megawatt. Currently it's a 12 megawatt. So onshore turbine and offshore turbine. Onshore turbine is when you are placing turbine on the land, when you are placing in the sea, that's called offshore turbine. The advantage of onshore turbine is installation. So installation is a little easy. But here the installation is the cost. The cost wise it is a low cost, but 3 times of the onshore cost. So here it's a 6 crores, but it is 18 crores. Almost 2.5 to depends on the number of capacity. Then it can come down. The cost will come down. But here the surface is very rough because many obstructions are there. Here the no surface is a very smooth surface. And also the wind speed will be very high, but wind speed will be not high. So that is advantages. And the control system we have to control. So wind turbine control objectives are to optimize the power production. So one, we have to do the optimize the power production in the control system, and it got to reduce the load and compliance with the grid and also disturbance of the mitigation. This is the control. I told you there is the control system. Why do you want a control system? When I have the low wind speed, my blade has to try to extract maximum energy from the wind, and also the same time it has to reduce the load on the turbine, and also it has to comply with the grid. So grid, you know that the transmission line. So we have the grid code. All this the turbine has to comply with the grid. Otherwise, the grid will get damaged. Yeah. So the power optimization, low wind speed, the power control concept, power limitation, and high wind speed. The different turbines are there. These are the turbines: stall control, pitch control, and active stall control turbine. Stall control turbine. Most of the turbines, I have shown there. There is the hub is there. The hub which has the three portion: 1, 2, 3. This is the blade portion, right? So here the blades are firmly fixed on the hub. There is no movement. I mean, the blades are firmly fixed on the hub. There is no movement of the blade. So what will happen? It has been designed because I have to control my power, entire power. It means that at low wind speed up to the rated power, the flow is streamlined. Just it will flow on the blades. When the wind speed is high, then it will create, there is a turbulence in the lee side of the blade. Then what will happen automatically? It reduce the power. So once it reduce the power, now you can see how it will reduce the power. See here, this is the wind speed, this is the power. Then it's increase the wind speed, increase the power also increases. When it reaches the rated wind speed, the power will come down. Then above the wind speed, above the rated, this is the rated wind speed. Wind speed is rated wind speed. Above the rated wind speed, the power will come down. So that is the power control. And that is, you can see here at 8 meters per second, just to slide on the blade. When it reaches the 24 meters per second, it's making the turbulence. And the other kind of turbine, that is a pitch control turbine. That is a pitch control turbine. You can see the blade rotates its own axis, just its own axis. So -5 to 180 degree it can turn the blade itself, just it can turn it. So what is the advantages? So for this one, you can see the power curve. So when the wind speed increases, the power also increases. Even the wind speed increases beyond the rated, this is the wind speed, rated wind speed. Even if it goes beyond rated wind speed, like 16 meters per second, 17, 18, 24 meters per second, the power is constant because the blade is adjusting the pitch angle of attack. So angle of attack is nothing but this is the angle of attack. This is the aerodynamic. So this is the wind speed. No, this is the when you divide the blade, divide the aerodynamic blades into two halves. So the line joining between this is called, that is the leading edge. Leading edge is called the trailing edge. This is called the chord line. So when the wind hits on the surface, this is the line. There is a chord line. When the wind is coming from this direction, so this is the wind. Then in between this chord line and the wind direction, that is an angle of attack. So this angle of attack automatically adjusts the angle so that it can always maintain the power. Even if the wind speed is increases, it maintains the power so that can easily extract energy from the wind. So this is the pitch regulation. Even the wind speed 20 meters per 24 meters per, still it is streamlined flow only. So this is a yawing. So yawing means, then I told you, the entire rotor system. This is the drivetrain. You can see drivetrain. So the entire nacelle portion has to turn towards the direction of the wind. For example, now the wind is coming from this direction. You can see the top of the tower. We have this kind of arrangement. The arrangement, there is a gear. It is there. It's running by the motor, right? So when the wind is coming from this, entire rotor comes towards this direction. When the wind speed is coming from this, direction, the entire rotor moves towards this direction. That's called yawing. So this is the wind electric principle I told you. And also the generating voltage. So this is less than 500 kilowatt and greater than 500 kilowatt. The less than 500 kilowatt will generate 415 voltage, and greater than 500 kilowatt will generate 690 volts. So 690 volt. Then after that we bring it down, and the transformer will step up the speed from 11,000 volt to 33,000 volt, and our frequency, that is 50 hertz. So this is about that generators. Now we have seen the many components. the types of electric generators, mostly we use synchronous generator, asynchronous generator, and a synchronous generator. Even this asynchronous generator, we have the squirrel cage induction generator, wound rotor induction generator, optic slip, doubly fed induction generator, and synchronous generators. Right. So what is the difference between our thermal power plant and hydraulic power plant and wind turbine power plant generators? So the wind electric generator always it has to be connected to the grid. If there is no grid, the generator will not run. Why? Because it is a mixing power. It's not that it's a main source. Generally, the base power is from the thermal resource. So from the thermal power plant, it generates electricity. It goes through the transmission line. So like river, for example, Ganga river. So Ganga river is coming like this, right? This is a canal. This is a small canal. When it's joining together, join with this Ganga river, the flow will go. In case the Ganga river is now stopped, there is no water from here. Then with the small canal is here, it cannot reach to the sea, right? The same way also. So this is renewable energy resource or mixing resource because it is the this is because of variable generation. Variable generation, there is a mixing. That just it's a mixing together only. So that's why mostly for 80% of the power from the thermal, conventional power plant, 20% from the renewable energy resources. But in our country, maximum Tamil Nadu, we have reached 45% from the renewable energy resources, remaining from the thermal energy resources. So that's why the generator always to be connected to the grid. There are two different types of generator: induction generator and synchronous generator. So now the induction generator principle, you know that. So the induction generator has the stator and the rotor. The stator, which is always connected to the grid. So it will initially drop from the drop current from the grid. So the grid, once it drop power from the grid, it is it's working basically.
Sir, your voice is breaking, please. Hello, sir.
Reducing? Yes.
Your voice is breaking continuously.
Oh, okay, okay then. Can you hear me now? Now it's okay.
Yes, sir. Yes, sir.
Okay, Nazar. Yeah. Maybe
Yes, sir.
Yes, sir.
Okay. Otherwise, maybe my this thing. Okay, right, sir. Yeah. So the induction generator. This is the construction. This has both the stator and the rotor. The stator, which is always connected to the grid. The rotor is there is no connection, right? It is separately. It is a squirrel cage induction generator. It has the wall. So when it will drop out from the grid, it will act as a motor, right? It will act as a motor. Then once the motor, then it will create the electromagnetic force. Once the electromagnetic force is created, it will induce the EMF to the rotor. Okay, now the rotor, which is actually coupled with the shaft, that is the high-speed shaft, right? So now now it will act as motor. So when I have there is a more power from the wind, it means that more power, there is more mechanical power, there's a torque is more from the wind. Then what will happen? It will push the power to the grid. Now it is going the reverse action. Now the power goes to the grid, right? So this is the way then its induction generator is working. And other one is the synchronous generator. So synchronous generator, both this also has both stator and the rotor. Stator is connected to the grid. The rotor also is not connected to the grid. We are giving there is external field. So external, that is a DC field will be given to the synchronous generator. The DC field always, this also will create the magnetic field. See, finally we want the magnetic field. The magnetic field has to be cut. Then only it generate electricity, right? So initially to drop power from the grid, here already have the magnetic field, and this field join together, then it will generate electricity. So there is a different concepts are there. There is a Danish concept, doubly fed induction generator, direct drive synchronous generator. So this is the fixed speed turbine. Sir, the time is there or hello? Hello, sir. Can you hear me?
Yes, sir. Sufficient time.
Yes, sir.
Yeah,
Yes,
I have
sir.
time now. Under 10
Yes.
minutes. Okay, okay.
Yes.
So this is a fixed speed turbine. So what is a fixed speed turbine? The rotor, this is a fixed speed or near constant turbine. What is the fixed speed turbine? So it always not the exact fixed speed and near constant, not exactly constant speed, right? So that's why it's the fixed speed turbine or constant speed turbine. For example, it's rotated 10 RPM, right? Okay, this is the gearbox. You know that the gearbox is the rotor is coupled to the gearbox is coupled to the generator. That is a squirrel cage induction generator. Then the power it goes through the soft starter because to avoid the inrush current to the generators. And this is the capacitor bank for generally the induction generator since the power is extracted from the grid, then when the turbine which starts, it's needed 7 times of the current, 7 times, 5 to 7 times of the current. Then it has to all of a sudden it has to draw from the grid. Then what will happen? All of a sudden the grid, the many number of turbines are there. When it draw from the grid, then automatically that the grid will dried up. Then it will stability will go. To avoid such a things, it has been placed at the capacitor bank. Right. So this is the near constant speed turbine. So constant speed is always rotated at the constant speed. It means that not constant. That is the slip. That is the slip. That is equal to ns minus n divided by that is the ns. That is the slip. The slip percentage will be 3 to 5%. So this 3 to 5% the slip only. Then the generator is running. You can see here the operating rate. That is 3 to 5% the variation. The torque variation will be there. Now you can see the speed and the torque. So the speed is even the increase the speed. I mean, the torque variation is very, very, very less only. This is small, but a small change in the torque variation, large change in the power will be there, right? So this is that this variation, this the 3 to 5% the variation will be there. Then it's operating, and the variable speed. Since the wind speed is varying, and also then we have to vary the power also, right? But the variation of the power, then how I can accommodate my grid? My grid frequency 50 hertz or plus or minus 49.5 and 50 point plus or minus 3% only can be there. I mean 50.3 only can be there. My grid frequency, right? This is my grid frequency. It is grid code which allows. But if it is beyond that, if I since it's a variable speed, the frequency may go to 58 to 60 also. How I can accommodate to the grid? Cannot be done it. So that's why it has a limited variable wind speed turbine. So the limited variable turbine, the stator, the generator stator has a resistance. So the resistance resists the power. So that resists the power means I can control my rotor speed. That is the way it's controlling the rotor speed. Then remaining configurations are same for variable speed wind turbine. Now you can see the torque operation, variable speed wind turbine. So previously you have seen only the small portion only. No, only the small portion only we have the variation is the torque variation. But here that wide speed range we can get it. I mean that 10 to the 50% also we can get it. The slip depends on the turbine capacity and also depends on the turbine design, right? So this is the doubly fed induction generator because the previous one. Now you can see the stator here, stator and rotor both are connected to the grid. Stator also connected to the grid. Stator also connected. The rotor also connected to the grid. That's why it's called the doubly fed. 2 times you are feeding. That's why it's the doubly fed induction generator. The rotor gearbox will be there. There is a wound rotor induction generator. Here is the rotor is there. Stator and the rotor. Now we can see in between the stator which is the rotor which is connected to the grid via the converter. This converter will convert AC to DC, then DC to AC. Why mean? Now I told you because see the variable speed wind turbine it varies the power also, correct? Varies the power. Power means that the frequency will vary. Then how I can bring it to the constant frequency? Now when I change it the AC to DC and DC to AC, I will decouple the mechanical and electrical frequency. Mechanical and electric. I'll decouple. Once I decouple it, then finally I can give it to the grid. So that is there. And this is general configuration of this one. Yeah. So initially the stator rotates at 1000 RPM. The stator field because initially I draw current power from the grid. Then it induces the electromagnetic force. The electromagnetic force, the field will rotate at 1000 RPM. 1000 RPM, but the rotor at a low wind speed, the rotor rotates only 900 RPM. How it will work? Actually, this is the hybrid machine. This is the hybrid machine. Okay, low RPM at 900 RPM only rotating. How it can generate power? Either it has to be more or it has to be together at 1000 RPM because the stator field is 1000 RPM. Now, what will happen? Just to draw the power from the grid, the rotor. Once the power goes up, what will happen? Now it automatically, rotate together. Now it will generate electricity, then it goes to the grid. This is the synchronous method. This is called the subsynchronous. That is at low wind speed. When it goes at the high wind speed, yeah. when it goes to high wind speed. For example, this is the rotor speed always 1000 RPM only. This cannot be changed. But here now the wind speed, now the wind speed is very high. You can see here now the wind speed is very high. My rotor speed is 1100 RPM. This is 1000 RPM. Now it is 1100 RPM. Now it's rotating in the opposite direction. Then 1000 RPM. Now what is happening there? Rotor also generating power and is pushing to the grid. Stator is 70% of the power is flow through the stator and 30% of the power flows through the rotor. So this is called, there is a double-fed induction generator and some of the turbine. There is no gearbox. See, I told you, so it's a 10 RPM. This is a 1000 RPM. In between, I need the gearbox because I want to step up. But this kind of turbine, there is no gearbox. This is the rotor, and it's directly connected to coupled to the generator. How it is possible? Speed is equal to 120 F by P. P is nothing but the number of poles. If you increase the number of poles, decrease the speed. Correct. That is inversely proportional. That is, that number of poles. Number of poles is, that is 100. Then speed can be accordingly adjusted. Right. So this is the way then we have it has been designed. There is a direct drive turbine. Yeah, so this is onshore turbine has been designed. It's largest capacity 5.4 megawatt, recently installed by Vestas. Right, I told you the best limit. This is the world largest turbine. That is a 12 megawatt capacity. It's installed in offshore GE. It's one single turbine. So one single turbine, the capacity 12 megawatt. The rotor diameter is 220 meters. Almost two grounds of football, two football ground and 1.5 cricket ground. So that much rotor, the diameter of this one. Even the height is at 260 meters. You can see there is a 260-meter height. So 260-meter height, you cannot imagine. So this much, it can, the capacity factor is 63%. Right. So this is an offshore turbine. So you can see the comparison. See our 260-meter turbine almost is Eiffel Tower, that is 324 meter. London Eye is 135 meter, and the Empire Building is, that is a 443 meters. So this is just for comparison. It has been given. Yeah. So this is the offshore turbine. When you are comparing the cost, the onshore turbine mostly the turbine cost will be more, but onshore turbine cost and the electrical cost is electrical and the foundation cost will be more. So this is the sharing of cost. And yeah, so the research areas. So research areas, since you are the mechanical engineer, electrical engineers, can do that's a lot of research in the wind energy. The first is the technology innovation. So initially it was nothing, just the rotor diameter was only 30 meters. That is a 200 kilowatt machine. Then before that it was 55 kilowatt machine. The initial stage it was 12 kilowatt. Then 12 kilowatt the first turbine, first electrical generating turbine. Next it comes to the 55 kilowatt. It's many of the location it is there. And next 190 kilowatt, then 200 kilowatt, 250 kilowatt. Like that it has increased the capacity. Now in India we have the capacity 3.5 megawatt single turbine. Right. So what is the technology innovation? Technology innovation, since the turbine capacity is increasing, then we have to reduce the weight of the blades. Reduce the weight of the blades for each ton. So each blade for 12 megawatt machine, each blade weight will be the 30 tons will be there. 35 tons will be there. Single turbine weight. Right? How we can reduce the weight, and also the materials. What is the kind of material you can use it? And also many of the now the latest turbine has, that is IoT technology, Internet of Things. How we can easily interact with the turbine, so that we can increase the efficiency of the turbine. For example, the wind speed is coming from there. The rotor has to orient towards the wind direction, then only can increase the capacity of increase the efficiency of the turbine. Then we have to sense the wind speed. What is the wind speed? Then we can increase the efficiency of the wind turbine. And also the independent OEM technology. Currently, we are associating with DTU Denmark. We are doing this OEM technology, and also reduce the usage of reinforced glass fibers, and also the invent a new control management system, and also now, the grid code which says that every turbine has a LVRT, low voltage right through. Even for 3 second or 5 second, the wind power is not there, then the turbine has to go through. It means the turbine has to run. That's called this low voltage right through, and also the high voltage right through, and also the power forecasting. So wind and solar power forecasting model development. So I told you then we are having so we have developed our own model for the wind and solar power forecasting. The wind power forecasting now currently we are giving services to various states. State-wise, 27 gigawatt we are giving. I mean 27,000 megawatt forecasting. It is being given by us, our team. Yeah, so the design optimization, how we can optimize the design and for siting and operation through an improved understanding of complex physics governing the wind flow. Still, it is going on. The complex flow, either flat terrain and complex terrain, the hilly region, because most of the hilly region they may not have the power. How we can utilize, because mostly the hilly region will have there is a high power, and also next generation wind technology increasing the performance. Many technologies that you can see in the net, because I do not have the time. So then many technologies, the different technologies, the next generation wind turbine is there, and how we can integrate the power into the grid. Already, even though we are integrated the power, still it's going on the research, and how we can workforce deployment for education. There is a capacity building we can give. So that's all, sir. Yeah, thank you for listening. If you have any question, I can answer.
Thank you, sir, for a lot of information in this 1 hour. Can I ask you, sir, one question?
Yeah, please, sir. Yeah.
Sir, this is Dr. KB Sutar. I want to know what are the safety issues related with wind turbines?
Specific issues, there are many components, even the blades. Blades, many of the locations, the blades got failures. Right, sir. And one thing, then after that, after 20 years of life, then many of the blades and the components are getting, then we have to dismantle it or decommission it. What are we going to do after that? The technology, and some of them have developed some technology. Okay, sir. How we can reutilize these materials, right? Yeah, so that is it. Then many other issues are there, and many components, even for gearbox failure, how we can, again, optimization. But the technologies is the old technology only. But, even keep on improving the design methods, different designs. Yes, sir. Yeah, I hope you understand, or
Yes,
you
sir.
need
Thank you.
the
One more
yes,
question.
sir. Yeah.
Can you once again explain the yaw mechanism, that direction
Yes,
control
sir. Yeah.
mechanism of the wind
Yes, sir.
turbine?
Yes, sir. So this is, now the wind speed is coming from this direction, sir. Right? Can you can see now this board? Yeah. Now the wind is coming from this direction, then automatically the rotor rotates in the same direction. See, all of a sudden the wind has changed into other direction. Now the wind is coming from the western direction. This is the east direction. Now it's the western direction. This entire rotor, this nacelle and nacelle and the blades and the rotor, it has to move towards this direction. This is called, let's say, yaw. Okay, sir.
Yes, okay, sir. But how exactly this happens?
No, because here we have wind. Here we have the wind direction vane. Wind direction vane will be there. Now the wind is coming from this direction. This wind vane will say that the wind vane automatically rotates the direction. Now all of a sudden the wind direction changes. The wind direction moves towards this direction. This information will be given to the slave controller. Where the slave controller to select the slave controller to collect the information. Then it will pass to the master controller. The master controller, okay, then it wait for a few seconds. Then continuously just will pass information. Then wait for a few seconds. This master controller will say that now please turn the rotor towards the western direction. Then automatically the rotor goes to the western direction.
Okay, sir. Okay. Thank you.
Yes,
So
sir.
next question
Any
is
other question?
regarding the lightning issues, like lightning.
Yeah. Yes, sir.
I would like to know from you, sir.
Yes, sir. So lightning. So most of the location we have the lightning. The each blades have the lightning rod. So lightning rods will be there. It brought to the ground. lightning arrestor will be there.
Sir, one more question.
Yes.
A lot of times we hear that there are a lot of Chinese companies.
Yes.
They are in the market of micro capacity wind turbines.
Yeah.
So any Indian company or the investors, they have done some research or they are actually supplying the micro capacity wind turbines?
Many are there in our country,
Okay.
sir.
Okay.
You can go through website even 500 watt turbines.
Okay.
Okay, even 500 watt turbines are there. 500 watt, 1 kilowatt turbine, 2 kilowatt turbine, 5 kilowatt turbine, 10 kilowatt turbine. In Indian makes are available.
Yes, sir. Thank
Or
you.
you can do your own design, sir. So you do not want to buy also. Students are there. You can ask them to design for 500 watt turbine. Nothing is there. Easily they can design. You can improve the efficiency of its aerodynamic. You can generate the power.
Okay, sir.
Sir, good
Thank
morning,
you.
sir.
Hello.
Sir, good morning. This is Karthikeyan Professor from Kadalur, sir.
Yes, sir. Tell me, sir. Yeah.
So we also do maintain wind database by making use of a many professional equipment. So is there
Okay.
any provision for us to share it for the benefit of the people, so that whatever the velocity that we are getting in our location can be made visible to others? Is there any possibility for us to upload the data
Yeah.
into any of the
You can
recognized
upload, sir. Yeah, you can upload, but we do not know how it is reliable. That is, a reliable thing should be there. How you are measuring it, how you are maintaining the instrument, how
Are
you are
there
calibrating the instrument, where you have placed your instruments. So it maybe we can take in it. There is a basic information, but for exactly for like what we are doing it when we are doing the site selection itself, we'll take proper site selection and instrumentation will make it in the properly. So that is the way then we do it. But whatever the information you have it, that is a good thing. Then you can share the information through your web.
So are there any recognized way of doing it, sir? As you said, by calibrating with the help of a recognized
You
body,
can,
is it possible for?
yes, sir, yes, sir. No. You can send a request to us, and you know what the kind of instrument you are using, how long the instrument has been using by you, and where you have placed your meteorological mast, and what is the surrounding area, how it is there, whether it's a building or obstruction is there. Those things we have to see, sir. Then you can, get help from us.
So I have one more question, sir. Are there any legalized formalities required to be fulfilled for installing turbines for our
Yes.
requirements? Say for a domestic
Yes, sir. Yes.
requirement, do we need to inform or fulfill any formalities?
No formalities for some domestic application, just a small wind turbine, no need to get, approval from government. Suppose we want to subsidies, then you can approach TEDA, Tamil Nadu Energy Development Agency. You can approach Tamil Nadu Energy Development Agency. They are giving, subsidies to some of the turbines. Okay, not for all the turbines, some of the listed turbines they will give. Otherwise, then you can put even own on your place. But
So
the turbine has to be, safety. You should contain that the safety precautions are. Yes, sir.
So what is the limitation for installation without any such statutory formalities, sir?
No, sir, for small wind turbine, nobody's asking anything. In case if you want to connect to the grid for net metering, then you have to approach TEDA, or else that you can make it your own and you can use it your own. That's all. For small wind turbine. For large wind turbine, then you have to, because anyhow you are going to connect to the grid, then you have to approach electricity board. Electricity board guidelines are there. Based on this, then you have to install it.
You also pointed out that now, because of the development in technology, a single wind turbine can generate a maximum up to how many kilowatts? How many megawatts, sir?
12 megawatt.
12
Now the
megawatts.
research is going. Yeah, now the research is going on. The next step is 15 megawatt. Prototype is going to develop, and the next one is 20 megawatt.
So 12 megawatt. Whether the 12 megawatt plant is there in India or somewhere outside the country, sir?
No, outside the country.
In
Our
India,
country, we
what is
have
yes, sir.
3.5 megawatt single turbine.
3.5 megawatt is the maximum capacity for us. Okay, okay. Thank you, sir. Thank you, sir. Kind of you, sir.
ONSHORE, yes.
Good morning, sir. I have a question. I myself, Professor Ehrar Ahmed from Sabusiddi College, Mumbai. Sir, first of all, congratulations. You have given nice presentation and information. Sir, my question is, what are the various possibilities of wind turbine power in automotive manufacturing industries to control environmental issue?
Yes, sir. For manufacturing, the environmental issues may not be high, sir, compared to others. See, the manufacturing industry, they are manufacturing the blades, gearbox. Mostly in our country, they are doing the assembly. But the blade manufacturing company, only the blade manufacturing company, the inside the factory may generate some fumes because they are laying, the carbon fibers, their carbon and glass fibers, they are laying, and also they are molding it. When they are molding and when they are using resins, then it may come out that the fumes. That fumes, it may affect the human health, not the environmental effect. And for the other things, that generate, other things, the generator and others, these are the components they will make in assembly. For example, for tower, manufacturing the tower, either you can use it lattice tower or you can use the tubular tower. This is called tubular tower. Tubular tower is that is steel rolling. That's all. And for generating electricity, it's the green energy. Yes,
Wind
so
energy.
this is, wind energy, there is a green energy that is the manufacturing. During the manufacturing, only it may be some sound, it will affect the atmosphere, and only the blade manufacturing will be that maybe some issues will be there, not much. Yes, sir. Any other question?
Hello, sir.
Life of the wind turbine is 20 years. What are the maintenance issues, routine maintenance issues?
Question not clear, sir. Your voice is not clear. Can you please
What
repeat?
are the maintenance issues for the kind?
Sir, maintenance issues are there, sir. Maintenance means we have to do regular maintenance, right? So regular maintenance means every 6 months once the manufacturers are doing maintenance, right? And apart from this, in case we are not maintaining the turbine properly, the various issues are there. Sometimes, the cable lying from turbine to the bottom transformer, somebody will, steal the wires. And also the other maintenance, the gearbox. In case if you are having the gearbox, the problem is the oil change. If you are not changing oil continuously, the gearbox, get deteriorated. Then once it deteriorated, it will get failure, and the bearing failure will be there. And also sometimes the blades get failure because of the delamination, because the blades are, I told you, the blades are manufactured through lamination only. All the fibers will be laminated. The laminated and using glue. So once the glue goes, then automatically delaminated. So once it's delaminated, automatically the entire entire blades will be deteriorated. Then due to the imbalance, the rotor will thrown off by the wind. And maintenance issues, not maintenance issues. These are the maintenance problem will come. And the generator. So generator the heat. So it will always generate heat. How you are making the cooling of the turbines? Whether you are having the cooling of air cooling, mostly they use that is air cooling only. But the latest technology they are using, other cooling methods. They are using it. And the control system. The control system. So we have to maintain the control system. Once the control get failure, the entire turbine will not work. So we have to do the regular maintenance. Yes, sir.
Hello, sir. Good morning.
Yes, good morning, sir.
I am Ravindra Gode from RIT Navi Mumbai.
Okay.
So is there any success story behind this? Wind energy is most efficient and effective as compared to others.
Yes, sir. Yeah, even our country, it shows that out of 87 gigawatt, 37 gigawatt, out of 87, 37 gigawatt from the wind. For example, in Tamil Nadu. So Tamil Nadu, we have installed already 9,000 megawatt. So out of 9,000 megawatt, we are getting during peak windy season. Now we are getting 5,000 million units. We are getting it. Okay, almost not 5,000. That 5,000 megawatt we are getting during peak hour season. Our total requirement is that is the 15,000 megawatt power. 15,000 is the peak windy season. Then the 5,000 megawatt we are getting from the wind.
And what is the main?
In our country.
Yeah.
Tell me, sir.
On grid and off grid is which is better in that case?
Sir, large wind turbine is on grid. Without on grid, you cannot do the off grid. Small wind turbine, you can do the off grid because off grid means we need battery storage.
Okay.
Off grid is always the battery storage. Large wind turbine, if you want to store the power, you need the large capacity of the battery bank. Where you are going to keep it. The cost wise, even for 300 kilowatt, will go to 4 crore rupees for storage. 300 kilowatt, I am telling. Now we are talking about megawatt, gigawatt. Gigawatt means then we can do the storage. Not, I can't say that it's not possible. But the thing is that the cost wise is too high.
Okay. If it is small, then we can use off grid.
Yes. That's a battery storage. You can use it for 100 kilowatt or even 1 megawatt also we can do it. 2 megawatt also we can do it, but it needs a large space as well as large, battery bank.
Okay. Thank you very much.
Welcome, sir.
For small wind turbines, what is the range of wind speed required for that location?
3 meter per second, sir. Minimum 3 meter per second you need. 3 meter per second. Minimum for cut-in wind speed. This is it's a cut-in. That is a 3 meter per second. Then it slowly wind speed increase, power also will increase. When it reaches the rated power, then it will reach that is for even for 1 kilowatt also reaches at the rated power, rated wind speed.
Okay,
yes,
sir.
Yeah. Next.
Is there any question, participants?
Hello.
Yeah. Yes, sir.
Hello.
Hello.
May I ask one question, sir? What are the different funding opportunities are currently available for this wind energy?
Pardon. No, voice is not clear. Please.
What are the different funding opportunities are currently available for this wind energy?
I'm not clear this question. What are the different? Sorry. Yeah.
So funding agencies are available.
Okay. Funding, sir. Funding is then if you want to do, then funding is not there. Okay, subsidies they may give for the in case you want to install, they will give that a subsidy. That is a one way, right, sir? For example, wind to solar hybrid. If you want to wind to solar hybrid for your house, wind solar hybrid for your house, then they can give the subsidies. Maybe 50%, 30%, 40%. They can give the subsidies, right? So that is it. Then other thing is if you want to do any project, then you have to write a strong project, research project. Then you can approach government, either MNRE. So now currently MNRE are opened. Okay, so MNRE you can approach MNRE or DSP project. You can apply your research project. There you can get the funding. If you want to for a large wind turbine, if you want to go for large, then 3 ways. Then if you want to go for large wind turbine, if you want to develop wind farm, if you want to develop, but you do not, you have the money certain amount. So 30% of the money you have to invest. 70% from you can get it from the bank. Many banks are there, and the main thing is that is the IREDA, Indian Renewable Energy Development Agency. They can provide the funding. These are the funding agency, banks and the IREDA. IREDA is the main funding agency, is under the Ministry of New and Renewable Energy. MNRE.
Thank you, sir.
Thank you, sir.
Okay.
Any other participants who want to ask a question? Shall we conclude, sir?
Yes, sir. Yeah, please.
Thank you, sir. Now we will conclude the session. I hope all the participants have enjoyed this session. Thank you for your attention. On the behalf of Bharati Vidyapeeth deemed to be University College of Engineering, I am very much thankful to Dr. K. Boopati for such a wonderful, informative and interactive session on the wind energy. Once again, thank you, sir, for joining with us. Thank you.
Thank you, sir. Yeah, thanks a lot for inviting me, and also thanks for the participants. If you have any question, they can send a mail to me. Okay. Thank you.
All participants will be closing this session now. The next session will begin at 2 o'clock. The feedback forms and the quiz for yesterday were sent to you via mail and they are open until 5. So please fill them and we'll see you at 2 o'clock. Thank you.